welcome back to Java Technograph. This is in continuous of our previous discussion about linked list. So let's continue our discussion. So in the previous discussion, basically we have visited this class, a test class where we are trying to populate the linked list and test it. So we are able to identify some of the differences that that linked list differs from the list. That is why we are trying to incorporate linked list for a specific purpose. So let's dig into details, right? So these are the methods that we come across for the linked list. So the major difference is that we are able to apply some mechanism to handle the first and last elements of the collection, which is not possible with our with list based collections, okay, with array list. So with linked list you will be able to handle the first and last elements. So here I am trying to add the first element and last element for our collections, which is already defined over here. So I'm printing here, and then basically get first get last will return the 60 and 70, which are already added. And here I'm using peak first and peak last, pole first and pole last. So these are the few methods which are heavily used for the linked list. All right, so these are the major differences. So let's try to run this and see the differences. Okay, so basically if you see the last one after pole first and last, it has removed the elements, the first 10 and last one. Because I'm using the pole first and pole last, it has removed those elements and rest of the elements are in the collection. But for the rest of the methods, nothing has happened. It only returns the element of that collection. If you say the get first, it returns the get element of the collection. If you say get last, it will give the last element. So this is the major differences. So you have to remember these methods which are used for the linked list. Okay, from the interview point of view, so this might be the one of the questions that might be asked you. So other than that, they might ask you like what are the various types of linked list. Okay, so you have to remember these four types. So assume that this is our collection. Okay, so we have head and tail element. So in single linked list, basically the each element has a reference to the next element. Okay, so e2 to e3, e3 has a reference to e4, so they know who is the next element. Okay, in doubly linked list, each element has previous and the next element. So here e3 will have reference to e2 as well as e4. So coming to e4, it will have reference to e3 and e5. So that is that is called as doubly linked list. In circular single linked list, basically the tail element has a reference to the head. Okay, this is circular single linked list. In circular doubly linked list, tail will have reference to head and head will have reference to tail as well. So that is why it is called circular, because it comes to a circle, right? When you have tail reference to head and head reference to tail, it becomes a circle. So it becomes circular doubly linked list. So that is the this you should remember this. What are these major four types of linked list? Okay, coming back, going to the next question, basically you will be asked what are the differences from the performance. So from the size and memory, for the array, we are discussed that we will initialize the array. If you are trying to handle thousands of elements, basically you have to initialize the array to a specific valid size so that the memory operations would be minimum, because resizing happens drastically. So but whereas in linked list you don't have to initialize that the initialization happen dynamically because each element is linked to the next element, so the initialization will happen dynamically. So the deletion and insertions are expensive in array, whereas in linked list they have optimum performance. Okay, it's minimum because we don't have to disturb all the, if say for example in your collection you have 100 elements and you are trying to insert one element, only the previous and the next elements, so totally three elements will get distorted and rest of the elements remain as it is. Whereas in array, you all the elements get distorted because the index keeps changing and the consecutive memory has to be allocated. So that is the reason why linked list has a better performance than array. Okay, the memory usage is optimal for linked list. As we have discussed previously, the same logic applies. Because the memory, if you have to initialize for 1000 elements, the consecutive 1000 heap size memory blocks should be allocated. So there is a huge IO operations. Okay, so and also linked list is used to implement stacks, graph collections, which have huge weightage in the collection classes. They are heavily used in the recent architectures. So you have to understand linked list so that you can implement stacks and graphs. All right. So the methods